Hey, Reliability Gang, I'm Jonathan Guiney.
And I'm Brendan Russ, and welcome to Reliability Radio, a JLO production, ReliabilityWeb.com media brand.
So, Brendan, at IMC25, finishing up the week, it's been a long one, but one of the cool things that we've naturally seen over the last 15 or 20 years, the progression or the journey of vibration.
Yeah, when you go down to the expo halls of all these conferences, all these Reliability Web conferences, you see the hot new thing that's come out. You can see how technology has evolved and our utilization of it and what that means for like condition monitoring and predictive maintenance. And it gets really, really fun to look at it kind of exciting, right? Because we have that background in doing that all this time. That's like, wow, I wish I had this way back when.
Yeah, I mean, the user interfaces now are pretty slick. The analysis and the progression of it's been getting better and better. I mean, it's just one of those tools that has come a long way from, old analog devices through route-based PDM. Now we're talking about wireless vibration sensors everywhere and real-time data that we can make really actionable insights.
And you can suddenly do so much more with so much less when you have all these analytics at your fingertips. So with us to talk about today, we have Chris Sobota and Glenn Gardner from Waits. How are we doing today, guys?
Fantastic. Thank you for having us.
Thank you.
Tell us a little bit about yourselves and what you guys do.
Chris, I'll let you go first, sir.
Sure. Yeah. Thanks, Glenn. My name is Chris Sobota. I'm Senior Director of Solutions Engineering here at Waits. I've been in maintenance reliability for about 13 years now and started out as a diesel technician, actually, and then moved into vibration analysis roughly 10 years ago. And I've sort of been part of that realm now for about the past 10 years. So
boats, trucks, what kind of diesels?
Boats, trucks,
locomotives, everything in between. Awesome. Good deal.
Everything.
Anything that burns diesel.
Anything that burns diesel, Waukesha, Stirling engines, bore scope analysis.
Awesome.
Yep.
And my name is Glenn Gardner. I'm a mechanical engineer by education, and I'm proud to be the Chief Strategy Officer at Waits. Coming up on my 25-year anniversary in the reliability industry. I got old while I wasn't looking. I used to be the young guy. But
happens quick.
I know. I can't believe it. But thrilled to be a part of it. And I've spent basically my whole career in or around predictive maintenance. And vibration is my core passion.
That's awesome. So Chief Strategist for Waits, what does that job entail?
It involves digital transformation. As you guys mentioned in the outset, there are a remarkable amount of technologies that are changing the way that people consume, generate, and analyze data on the plant floor. And my job at Waits is to make sure that Waits is a critical part of that ecosystem and is serving customers well, not only in our core space of vibration, but in everything else. Where should that vibration go to give the best benefit to operators, even to supply chain, like everyone that needs to know the vibe information? My job is to make sure that Waits is able to transmit that data to the people when they need it.
So what do you guys think about this whole evolution, you will, of using these different sensors, right? It used to just be vibration. Now It's vibration, it's temperature, it's humidity. It could be, I don't know what time of day it is, and battery power and all this other kind of stuff. What do you guys see over the past 20, because we have like that long history, that 20 plus year experience. Tell us about what you see from your perspective.
So I like to break it into three different eras. Era number one, I'll call the analog era. That was the dawn of our industry. In those days, the men and women that were involved had to know everything about analysis. They had to be a mechanical engineer and an electrical engineer and many different disciplines all in one. And they had to carry suitcases worth of equipment in order to do an analysis. But I like to say the great news is once the analysis was done, it was only 3 months before you typed it up on a typewriter and sent it out to the customers.
Already blew apart by that time.
Exactly.
You blow my mind. 3 month turnaround. That's amazing.
Totally. So that was the dawn of our industry. We were a tiny cottage industry in those days. Everything changed in the 1980s when a company in Tennessee named CSI invented the route collector, the famous CSI 2120. And so all of us in the industry owe a great debt to that product. What it did for the first time was it allowed people to separate the analysis of vibration data, as would typically done by an engineer, from the collection of data, which could be done by a trained technician. That one hardware product ushered in everything that we know of today as level 1, 2, 3, 4 certification in vibration, and it exploded the market. There was a huge expansion in the market size, and basically all of us are here today because of that explosion in the size of the vibration market. So we all owe a debt to that famous 2120 and all of its successors that came after it. And the exciting thing is we're now in wave 3. Both Chris and I, one of our first jobs out of school was to run around with those vibration route collectors to collect data. So it holds a special place in my heart, but it is not the future of vibration analysis. Thankfully, we're now able to install a complete plant's worth of sensors, have them wirelessly transmit over a air-gapped network, meaning not on the plant network, and transmit data to the cloud where we can deploy all of the fun tools that we know and love, like machine learning and AI. And I'm excited to be a part of this third wave and can't wait to see where it goes. And I'm happy to recklessly prognosticate on where we might go next if you guys would like.
Well, where are you thinking it's going?
Recklessly? All right, okay, curious. Let's hear this.
I know. So first of all, right now, most of the AI and ML happens in the center or in the cloud, as contrasted with the edge. It's a fractured industry in that you have some AI that goes after plant historian data or time series data. Our AI, for example, specializes in interpreting time waveforms and frequency spectra, which is vector data and very different from what you would find in a plant historian. What I'm excited about is as time goes on, we'll be able to embed these models closer and closer to the edge, so the individual sensors will be able to have a lot of intelligent diagnostics. Whereas today I would call it maybe a 10-90, 20-80 split, where 80% of the computational horsepower happens in the cloud. In the future, as these chips become more and more powerful, we're going to see a lot more edge computing, and that's going to get pretty exciting.
And what does that do for the industry?
So it helps you have the local data on site so that you can send it to a SCADA system, for example. One of the challenges right now that is tough to avoid is AI applied to vibration data kind of has to be done in the cloud because all of the AI tools that are pointed at plant historian databases can only take scalar time series data. That's a technical point, but it's a really important one. Your standard plant historian can't handle data like thermography and oil analysis and vibration.
Because of the massive amount of data that it's dumping in it. Like all those FFT lines, all of those samples over and over again, they make that spectrum and waveform information. That is an inordinate amount of information to crunch through.
You got it. A huge amount of information. And ironically, the plant historian can handle enormous amounts of data. What it can't handle is the data structure. It can handle a completely enormous amount of scalar time series data. It was never built to be able to handle frequency spectra, oil analysis results, things like thermography scans. It's simply a different data structure, and the database behind the plant historians can't hold it. So it's really more about the data structure, I would say, than it is the size of the data.
So when we're saying about the data structure, and you're talking about these chips and computational power, it's not just the chips then.
Correct.
We're talking about having to structure it in a formatted database that's got this kind of standardization and being able to interoperably go between these databases, assign it to an asset, and then actually make a recommendation, right?
Exactly right. And so if you think about it, there's a reason why the reliability industry and the controls industry have always been separate. Like we're right next to one another. You would think there would be a lot more mixing, but if you were to walk the plant floor here, you're only going to find a handful of controls engineers. We're all mechanically oriented, guys like me and Chris that know our way around a diesel engine, know our way around vibration.
You mean you don't have a lot of guys walking around here that know how to do ladder logic and hexadecimal code?
Oh, well done.
Come on.
Well,
man.
at least we got one guy right here. That was impressive, Brandon.
Sorry.
But it is the case. And the reason for that, it's really not cultural, it's technical. The fact that everything that a controls engineer does exists in scalar time domain data, and everything that a predictive maintenance specialist like myself or Chris or you guys, everything that we do is more complex data. We say vector, matrix, and tensor data if we want to be technical about it. None of that has a logical home in all of the integration tools in the controls world. And so that's the reason why the two worlds are fractured. However, my big dream is it all comes together. So that's what's going to be so exciting about edge computing. Once we move towards edge computing, you'll be able to do the really difficult diagnostics right on the chip there. You'll be able to load the models directly in the chip's RAM and then send the outputs, which can be scalar, directly to the plant historian.
Do we have a model of this, like an actual case study of this in any kind of practice?
No, right now I've not seen any diagnostic algorithms broadly loaded directly into the sensor. The sensors do have their own internal diagnostic engines that simply say this sensor is working properly or not.
So When do you think something like this might be not just on the horizon, because we're looking beyond the horizon, it sounds like a little bit here.
Yeah.
When do we think something like that might actually come our way?
So the two pieces of good news here. First of all, I think it'll be 3 to 5 years, give or take. It'll all be driven by the development of the AI chips. That's what's going to drive the industry. We are the tail that'll be wagged by the dog of AI chip development.
So if we're going to start bringing in those 2 little letters, we got to talk about some stuff.
You got it.
So if we're going to start bringing in that and talk about how it's going to be integrated through an AI, how are you going to tie that into, say, an already existing infrastructure that already has, well, think about like 3 to 5 years from now, if we're talking about going into the expo hall, everything already has AI. You're not going to have competing AIs, dueling AIs. They need to integrate into something, to a singular system, regardless of what it's like. Forget about dashboards, just tell me stuff. Right? In this case study or model that you're trying to purport as the next wave of condition monitoring, how would that even look or feel? Or you're not just going to drop that in. You're not going to institute a new system. You need to add that to an already existing system that can then absorb those capabilities.
Correct. So here's the good news. We have the early stages of that today. Right now, the computations that we do in the cloud on all the complex data is using all of the AI and ML tools that we've been talking about. And then what it does is it integrates back to the CMMS, to a plant historian, to a SCADA system, but it only sends scalar data back to those systems. So today, all the computations that we do in the cloud, we needed the cloud for this first wave of development because we had to get hundreds and thousands of machines information into there in order to do the development of these models. Interestingly, once the models are developed, storing a trained model on a chip is a much different task from actually doing the training in the first place. And the same principle applies to LLMs and everything that's happening with ChatGPT and all of its competitors. In order to train a large language model, you need a bazillion data centers. It's enormous. It's the most computation we've ever had in the history of humanity. However, once you've done that hard work of training the model, you can actually fit an entire LLM just right on a desktop computer. That's the important distinction here. So this phase right now that we'll be in for the next, say, 3 to 5 years was always inevitable. It had to happen in order to get the models trained up in the first place. Once we have that, we're going to be able to embed that directly into the sensors on the plant floor, and then we won't have to transmit as much data up into the cloud.
So here's one question I have, right? So now we got into the AI conversation with all this edge computing on the device. A lot of software providers in the vibration area right now always rely on a level 3, level 4 CAT guide to go out there and actually validate confirm whatever it is, the data that they're seeing, the recommendations coming out of that device. Does that all get replaced?
I don't think so. So I believe that if it ever does get replaced, it's on the 20 plus year horizon, something far enough away that it's not meaningful today.
Might as well start talking about quantum computing.
Exactly. Yeah.
So where does that happen then, right? If we're talking about sending this data from those edge devices out to a SCADA system or another data platform, where does that third party come in and then make that recommendation?
So they would be able to view the data after it's gone through something like a SCADA system. So in the event of an anomaly, or in the event where an algorithm flags a problem, you would be able to stream that data, not the other 100,000 pieces of data that you took that didn't have an anomaly in it. You would stream that data directly to a trained analyst. I always like it best when a trained analyst, I'll represent an analyst myself, and Chris is both an analyst and a trained technician, that he's been a certified diesel technician, so he knows exactly what he's talking about on the floor. I think you will always need both of those because Chris will spot things that I as an analyst will not, having had his hands on these machines for so many years.
So you're telling me the model can be trainable based upon somebody's actually input and review of that then?
It can be trained and it can be improved. I'll go on record in 2025 saying we are a long way away from these algorithms being able to completely eliminate technicians. I don't see that happening anytime soon. And in fact, I think the most important thing we can do for the industry is ironically not double down on the algorithms, but double down on trained technicians that are interacting with analysts. And then both parties learn a lot in the process.
Amen. Now, obviously, we got a skills gap out there. We've got younger people entering the workforce that don't have the same knowledge as the people exiting, and it's a huge area of concern for all of us. So really appreciate you guys jumping on the podcast. As we wrap this thing up, any last nuggets, words of wisdom, things for our audience to think about as they start to engage a company like yourself?
Yeah, what I would say is if you're in reliability, please, please, please reach out to other folks that are doing digital transformation outside of reliability. Our biggest risk as an industry is if we remain siloed and we don't have our data going to other parties like operations, like IT, like engineering, digital transformation will happen and we will continue to be a stepchild. I don't want that future. And so my big thing is I want all reliability engineers and maintenance technicians to integrate and to talk and to have as many interactions as you can with your brothers and sisters in ops and engineering and IT.
Chris?
Yep. My big one is diversify your skill sets. Find a way to improve upon what you currently know, make yourself more valuable, and look at different skills that you're going to be able to implement and be able to be a thought leader in your space or for your company because you're able to understand a much larger, broad set of skills for future applications and decision making.
Well stated, sir.
That's like a reliability guy knowing about controls engineering. Right?
That's right.
Well, thank you both for being with us today. And for everybody else out there, we'll catch you next time on Reliability Radio.